Let's determine what's oxidized and what's reduced in each of these reactions. We'll also identify the oxidizing and reducing agents. Let's quickly recap what oxidation is. So you can use the mnemonic Leo the lion goes grr. What that stands for is loss of electrons is oxidation. And gain of electrons is reduction. So let's write the equation for the reaction between sodium metal and sulfur. Sodium is Na, that's a solid, and that's going to react with sulfur, which is also a solid. You can use the charges on these cations and anions to find the formula for sodium sulfide. Sodium has a 1 positive charge, and the cation does, and sulfide forms 2 negative anions, and they're going to combine in a 2-to-1 ratio, where you have 2 sodium ions for every 1 sulfide ion, and that's going to have a high melting point. That's going to be a solid. So let's take a look at this using Lewis dots. Sodium has 1 valence electron, and sulfur has 6. We're going to need 2 sodiums each to transfer 1 electron to the sulfur to become this ionic compound. So looking at this visually, you can say that sodium is oxidized because it's losing electrons. And sulfur is reduced because it's gaining electrons. Because sulfur is accepting electrons, it's also known as the oxidizing agent. And because sodium is donating electrons, it's also known as the reducing agent. Now you can do the same thing using oxidation numbers or oxidation states. Sodium has an oxidation state of 0 because it's in its elemental form, and so is sulfur. But in the compound, sodium has an oxidation state of +1. So you can see its oxidation state has increased. So it's oxidized. And sulfur has an oxidation state of -2 in the compound. So because its oxidation state is reduced, sulfur is reduced. All right, let's move on to part B, aluminum and oxygen. Aluminum is a metal, so we'll indicate that with a solid, and oxygen is a diatomic gas. Again, we'll use the charges to find out the formula. For aluminum oxide, aluminum forms 3 positive cations, and oxygen forms 2 negative anions. You can crisscross these numbers on the charges to find the ratios that they'll combine in. So the formula for aluminum oxide is Al2O3. And it's also going to have a high melting point, as most ionic compounds do. Sorry, I just realized I didn't balance the equation for the first reaction. So for the balance equation, we need a 2 in front of the sodium on the reactant side. All right, so let's not forget to balance this one. We need a least common multiple of 6 oxygens on both sides. So I need a coefficient of 3 in front of the oxygen and a coefficient of 2 in front of the aluminum oxide. And I need a coefficient of 4 to balance out the aluminums. So similar to the first reaction, let's show this visually using Lewis dots. Aluminum has 3 valence electrons, and oxygen has 6 valence electrons. It's a nonmetal. So aluminum is going to want to transfer, like most metals, it's going to want to lose its electrons to the nonmetal. So therefore, aluminum is oxidized. Oxidation is the loss of electrons. And since oxygen is gaining those electrons, oxygen is reduced. The oxidizing agent accepts electrons. So you can say oxygen is also the oxidizing agent. And aluminum, because it's donating electrons, is also known as the reducing agent. And finally, we'll take a look using oxidation states. Aluminum and oxygen in the reactants are in its elemental form. So they both have oxidation states of 0. Now in the compound, oxygen normally has an oxidation state of -2. And therefore, aluminum has an oxidation state of +3. Because the compound is neutral. Alright, so notice that the oxidation state for oxygen is being reduced. From 0 to -2 is a reduction. So oxygen again is undergoing reduction. And aluminum is being oxidized.